All right. Let's talk about LabWork 13. All right, so what we have here is a bunch of variables raised to a power, multiplied and divide. So we have to talk about the rules of exponents, right? So if I have x to the a times x to the b, that would equal to x to the a plus b. And if I have x to the a divided by x to the b, then I'll have x to the a minus b. Okay, so that's the essential rules that we got to use. And then about the negative exponents. If it doesn't like be on the bottom, it can be on the top. If it doesn't like be on top, it can be moved to the bottom. So a couple of ways of thinking about this particular problem. One is I see that negative exponent on the bottom. It clearly does not like being on the bottom, so therefore I'm going to move it to the top. So I'm going to have x to the 4/3 times x to the 6/5 times x to the positive 1/2, because it doesn't like me on the bottom, so let's go ahead and move them to the top. Since this is all multiplying, what I can do is now say it's x to the 4/3 plus 6/5 plus 1/2, right? Now, the downside of this is that I have to get a common denominator. What do they have that I don't have? So let's go ahead and blow this up a little bit more. So let's go ahead and take this right here. All right, let's see if I can. It doesn't like to move. Okay, so what I'm going to do now is go, okay, let me take this right here and I'm going to bring it over. So I have 4/3 plus 6/5 plus 1/2. Okay, so what do they have that I don't have? So let's actually, no, I don't want to move. I don't want to do this. Yeah. There we go. All right. So what do they have that I don't have? Well, the 3 doesn't have the 5 nor the 2, which is 10, right? So I will multiply this by 10. Do it to the bottom. I have to do it to the top. The 5 is missing the 3 and the 2. So that'd be a 6. And the 2 is missing the 5 and the 3. So it's 15. So if you look at the bottoms, this, and this, if you look at 3 times 10 is 30, 5 times 6 is 30, 2 times 15 is also 30. So I have a common denominator. So essentially what I have here is 40/30 plus 36/30 plus a 15/30. Okay, so I've added all those together. That's what, 76, actually let me see. 36 plus 15 is 51, plus 40 would be 91. So let me just make sure. 40 plus 36 plus 15 is 91, so this would be 91/30. All right, so that means over here I have x of 91/30. All right, so that would be my answer, which is choice C. That's correct, choice C. All right. There we go. And down the line, there we go. All right, so that's number 1. All right, on to number 2. So this says to use rational exponents. And to use rational exponents, what we need to do is convert these radicals to rational exponents. Rational means fractions, exponents mean power. So my 4th root of y is going to be y raised to the 1/4 power, and the 5th root of y would be y to the 1/5 power. So there's my fraction there. Since I'm dividing, I'm going to subtract So it'd be 1/4 minus 1/5. Same thing, I need a common denominator, right? So what I really have here is that the 4 is missing a 5, and the 5 is missing a 4. So what I'll have is y to the 5/20 minus 4/20. So I have y of 1/20. Since it gave it to me in radical form, I have to put it back in radical form. So put it in radical form, I'm going to have something like this. So I have a y, and the power is 1, and the index or the root is 20. Let me see if I can write that better. 20, and there is my answer, and that is choice A. And there we go. All right. Let's see. All right. That's number 2. All right. On to number 3. All right. So number 3. So what I know is that my index is a 2, so we're looking for pairs, right? Or 2 of a kind. So okay, so what I have now is I got the square root of 2 times 2 times 2 times 2 times 2 times x times y. Okay, since my index is a 2, I'm looking for pairs. So here is a pair of 2's. Here's another pair of 2's. And here's a pair of x's. So that means what I have here is a pair of 2 comes out, another pair of 2 comes out, and a pair of x comes out. Well, what stays inside? What stays inside is what is not highlighted there, which is 2y. So really I have a 4x square root of 2y, which that would be choice D. There we go. There's number 3. All right, to number 4. There's number 4. Okay, so a couple ways of thinking about this. You can either divide first. You could, basically, if you're going to divide, you're putting it under all one same radical. You know what? Yeah, why not? Okay, so I could just call this let's see if that's enough. So I can say this is the cube root of 81, a to the 5th, b to the 6th over 3a squared. Okay. That being said, when I divide this is what I get to have. The cube root of 81 divided by 3 is going to be 27. A to the 5th divided by a squared is going to be a to the 3rd, and b to the 6th. Okay? So if I was to break that apart, what I have is the cube root of 3 times 3 times 3, that's 27. A times A times A. And then B times B times B. Let me do this. B times B times B times B times B times B. Okay. I got that. There we go. So that's what I have. And again, since my index is a 3, that means I'm looking for 3 of a kind. There is a group of 3, group of 3, group of 3, group of 3. So that's going to come out to be a 3ab squared. And that, ladies and gentlemen, is choice D. There we go. All right. So on to number 5. All right. Number 5. So what does this mean? This means that I'm going to write this parentheses out twice. 7 square root of 7 plus 3 times 7 square root of 7 plus 3. Okay? So then I would double distribute or FOIL. So I can write this out, expand it a little bit more. So it'll be 7 square root of 7 plus 3 times 7 square root of 7 plus 3. So what I'm going to have when I distribute, so let me do this. That's going to give me a 49 times 7, because square root of 7 times square root of 7 is just 7. I got this one right here, which is going to give me a positive 21 square root of 7. And I'm going to get this one right here, which is going to give me a positive 21 square root of 7. And last but not least, that one right there, which is going to be a plus 9. All right. So I got the 49 times 7. So that's going to be a 343 plus 42. Actually, you know what? Yeah. So this is going to be 343. If I add 9 to it, it's going to be a 352 plus a 42 square root of 7. And with that being said, that is going to be choice B. And there we go. All right. That's number 5. On to number 6. Okay, number 6. What I have here is basically 2 fractions added to each other. However, what I have here is, if I break this apart, essentially I have a square root of 2, which I cannot break down, right? So square root of 2 divided by square root of 4, which is just plain old 2, plus the square root of 8, which if you think about square root of 8, that's going to be a 2 times 2 times 2. And square root of 25 is just a plain old 5. Okay? So let's go a little bit further into this. So I got the square root of 2 over 2 plus, since I have a pair right here, that's what I'm going to actually do. So I'm going to have a 2 square root of 2 over 5. So in order to add these together, I need common denominators. So what am I missing? The 2 is missing a 5, so I got to do it to the top and bottom. The 5 is missing a 2. So I got to do it to top and bottom. So that means I'm going to have a 5 square root of 2 over 10 plus 4 square root of 2 over 10. Interesting. So I add or subtract the top, right? Which they are the same radicals. So I'll have 9 square root of 2 all over 10. And that, ladies and gentlemen, is choice B. And there we go. All right, so that's number 6. On to number 7. All right, so number 7. So a couple of things you can do. I already see like radicals, so for me, I would probably put them together right away. So I'm going to have this right here, which is 3x squared minus 7 times the square root of 108 x squared. Okay? Now I can break it down. So 108 breaks down to 2 times, what is this, 54? 2 times 27. So 2, 2, 3 times 9. So 2, 2, 3, and 3, and 3. Okay? So what I can do is say, okay, so what I have here is the square root of 3 times x minus 7 times the square root of 2 times 2 times 3 times 3 times 3 times x. Okay? So my index are 2's. So I'm looking for pairs or 2 of a kind. So there's a pair there, a pair there, a pair there, and a pair here. Okay? So awesome. So let's go ahead and see what we have left. So the x can come out with a square root of 3 minus 7 times a 2 comes out, a 3 comes out, and an x comes out. And all I have left under the square root is just a 3. Awesome. So I have x square root of 3 minus 7 times 2 is 14 times 3 is a 42 x square root of 3. So what does that give me? That gives me a negative 41x square root of 3. And that is choice C. There we go. Okay, so that's number 7. Let's go on to number 8. Okay, so number 8. The biggest part is going to be this part right here. Don't forget to distribute that negative through. So what I would have is 6 plus 4i plus 4 minus I. Okay, so the 6 plus 4 would equal to 10, and then the 4i minus I will give you a 3i. And that is choice B. There you go. All right, on to number 9. Rationalize the denominator. So this is what I'm going to do. So the first thing I would do is put parentheses around these. And since I want to get rid of the I in the denominator, I would multiply it by the conjugate. Okay. So what do I have on top? I have to FOIL or double distribute, so I'm going to get a 36 plus 12i plus 54i plus an 18i squared all over 81 minus 9i squared. Okay? So, what I really have here is I got the 36. Well, let me put it this way. So what this is really equal to is that this plus 18i squared is actually going to become a net minus 18. Because the I squared is negative 1, so it flips that positive 18 to become a negative 18. And this minus 9i squared is now going to be a plus 9. Because, again, I squared is a negative 1, so it makes that negative 9 a positive 9. So what I really have here is the top, which is 36 minus 18 to give me 18, plus a 66i all over 90. So what I have now is 18 divided by 90 plus a 66 over 90i, which both of those fractions reduce, and it's going to reduce to 1/5 plus 11 over 15i, which is choice D. And there we go. On to number 10. So completing the squares, the first thing I have to do is put in standard form, which would be ax squared plus bx plus c is equal to 0. So I got 8x squared minus 5x plus 1 is equal to 0 because I got to subtract that 5x over, and that's my second term. So the first step is to get rid of that 8 so that a could be 1. All right, so that means I have x squared minus 5 over 8x plus 1 over 8 is equal to 0. So the second step is to get rid of that old c. So I got x squared minus 5 over 8x is equal to negative 1/8. So I gotta find a new c. It's equal to b divided by 2 squared, which is equal to negative 5 over 8 divided by 2 squared, which is equal to negative 5 over 16 squared, which is equal to 25 over 256. So I got to add 25 over 256 on both sides. And then when I factor the left side, I'm going to have x minus 5 over 16 squared is equal to negative 7 over 256. And then I have to take the square root of both sides. So I'm going to have an x minus 5 over 16 is equal to plus or minus the square root of negative 7 over 256. So I got to take the square root of top and bottom. Okay, when I take the square root of top and bottom, I have x minus 5 over 16 is equal to plus or minus I square root of 7 over 16. Then I add the 5/16 over. I'm adding two fractions with a common denominator. So x is going to equal to 5 plus or minus I square root of 7 all over 16. And that, ladies and gentlemen, is going to be choice C. All right. So here's the answer key for LabWork 13. If you have any questions, let me know. Talk to you later. See ya. Bye.